I'll explain how changing the number of clusters in Scikit-learn's feature agglomeration affects the outcome. It's all about grouping similar features together to reduce the data's dimensions. Think of it like sorting toys. More groups mean more detail, but also more work. We're using feature agglomeration to reduce 10 features to 5, initially. Then, we'll explore what happens when we increase the number of target groups, clusters, from 5 to 10. I'll examine how this impacts the feature count and the computation involved. I'll break down how the change in the number of clusters, n_clusters, affects the results in a step-by-step fashion. This includes looking at the number of resulting features, the computational demands, data representation quality, and whether it changes the method of grouping, linkage. We start with a dataset containing 10 features. Think of each feature as a different characteristic we measure, like height, weight, or age. I'm using feature agglomeration, a technique to combine features, first aiming for 5 clusters, groups of features, and then increasing to 10 clusters. The goal is to reduce redundancy and improve efficiency. The outcome will be a reduced dataset, first with 5 features, after the initial aggregation to 5 clusters, and then with a potentially different number of features, after increasing the clusters to 10. This depends directly on how many groupings feature agglomeration creates. I'm exploring how changing the number of clusters in feature agglomeration affects the results. Think of it like this: we're grouping similar features together. A higher number of clusters means more groups, impacting how many features we end up with and how much computing power we need. I'm starting with a dataset that has 10 different characteristics for each data point. For example, if we were looking at houses, these might be square footage, number of bedrooms, location, etc. I set the number of groups, clusters, to 5. This means I'm aiming to reduce the number of features to 5 by merging similar ones. Now, I'm increasing the number of clusters to 10. This will result in more groups and a different way of combining features. With 5 clusters, I'll end up with a dataset that only has 5 features. I've effectively combined the original 10 into 5 representative features. If I use 10 clusters, my reduced dataset will still have 10 features because I haven't merged the features as much as before. I predict that increasing the number of clusters will lead to an increase in the number of features in the reduced dataset, because I'm creating more groups and less merging. I also anticipate that increasing the number of clusters will take longer to compute, because the algorithm has to work harder to find the best way to divide the features into more groups. I'm using Ward's method, which is a specific way of measuring the distance between clusters during the grouping process. It focuses on minimizing the variance within each group. Think of it as trying to keep the things within each group as similar as possible. It's a great technique. I'm investigating how changing the number of clusters affects the feature agglomeration process. Specifically, I'm focusing on how it changes the outcome, number of features, and the computational effort needed. I'm starting with a dataset that has 10 different characteristics, or features, for each data point. I'm increasing the number of groups, or clusters, from 5 to 10. This means I'm going to group my 10 features into 10 distinct groups instead of 5. Initially, I'm using a technique called feature agglomeration with 5 clusters. This process groups similar features together, reducing the original 10 features into 5 representative features. Think of it like consolidating related concepts. Now, I'm performing feature agglomeration again, but this time with 10 clusters. This will result in a different grouping of the features, and will likely yield a different set of 10 representative features. After the initial feature agglomeration, with 5 clusters, I've successfully reduced my dataset's dimensionality from 10 features to 5. After performing feature agglomeration with 10 clusters, I now have a reduced dataset with 10 features, the same number as the original dataset. This illustrates that increasing the number of clusters doesn't always reduce dimensionality. It's important to find a balance between dimensionality reduction and preserving useful information. That's a key takeaway. I'm comparing 2 scenarios using Scikit-learn's FeatureAgglomeration. In the first, I group the 10 features into 5 clusters. In the second, I increase the number of clusters to 10. We'll see how this affects the results. I'm starting with a dataset that has 10 different features. Think of these as 10 different characteristics describing something. maybe 10 different measurements of a cell. I use FeatureAgglomeration to group these 10 features into 5 bigger, combined features. It's like combining similar ingredients into fewer groups. For example, imagine combining several similar shades of paint into 5 larger categories of color. The result of the first grouping is that I now have 5 new, combined features. Each is a combination of some of the original 10 features. Now, I repeat the process, but this time I ask FeatureAgglomeration to create 10 clusters instead of 5. I'm aiming for more fine-grained grouping. The outcome is that I now have 10 combined features, each representing a smaller group of the original 10 features than in the previous case. I'm using word linkage, a specific method for hierarchical clustering. It works by minimizing the variance within each cluster. In simple words, it tries to create clusters where members are as similar as possible. With more clusters, 10 instead of 5, the computer has to work much harder to find the best way to group the features. It's like trying to arrange 10 objects into 10 groups instead of 5. More possibilities to check mean it takes longer. When I increased the number of clusters, the number of resulting features increased as well. This is because fewer features are merged together per cluster. I'm exploring how changing the number of clusters in feature agglomeration affects the outcome. Feature agglomeration is a dimensionality reduction technique that groups similar features together. The number of clusters dictates how many groups we create, directly impacting the number of resulting features. This is the core question. We're given a scenario. We start with 10 features and use feature agglomeration to reduce them to 5. Then we ask what happens if I increase the number of clusters from 5 to 10. We need to analyze the effects on the number of features, computational cost, data representation, and the linkage criterion. Let's dive in. If I increase the number of clusters, I'm essentially creating more groups of features instead of fewer. That means fewer features will be merged, resulting in more features in the reduced dataset. With more clusters, the algorithm has to do more calculations to figure out the best way to group the features. It's like trying to sort more items into more boxes. It takes longer. Increasing the number of clusters doesn't automatically mean a better representation. Sometimes, fewer, well-chosen clusters capture the essential information more effectively. Think of it like summarizing a long story. A shorter summary might be more impactful than a longer, less focused one. Nope. The linkage criterion, word, in this case, is a separate setting that I'm not changing. It determines how the features are grouped, not how many groups there are. This is our starting point, a dataset with 10 distinct features. I apply feature agglomeration with 5 clusters. This merges the 10 original features into 5 groups, reducing the dimensionality. The result is a dataset with only 5 features, representing the 5 clusters. Now, I increase the number of clusters to 10. I'm going for more granular grouping. The outcome: my reduced dataset now has 10 features, reflecting the 10 clusters. This is because fewer features are merged together. I'm increasing the number of clusters in feature agglomeration from 5 to 10. This means I'm changing the number of groups I want to merge my features into. Think of it like sorting toys. Instead of putting them into 5 boxes, I'm now using 10 boxes. This directly affects how many final features I get. I start with a dataset that has 10 different characteristics, or features, for each data point. For example, if my data is about houses, these features could be square footage, number of bedrooms, location, etc. I use feature agglomeration, a technique that groups similar features together. With 5 clusters, I'm merging the 10 original features into 5 groups of similar features. This reduces the number of features to deal with, simplifying the data. After the first feature agglomeration with 5 clusters, I have 5 new features that represent combinations of the original 10. Each of these new features is a summary of several similar original features. Now, I'm performing feature agglomeration again, but this time with 10 clusters. Instead of 5 groups, I'm making 10 groups of the original features. This means there is less merging of features. The result is 10 new, aggregated features. Because I used more clusters, I end up with more features than before. Less merging means more features survive. By increasing the number of clusters from 5 to 10, I directly increase the number of resulting features. It's a straightforward consequence. With more clusters, the computer has to do a lot more calculations to find the best way to group the features. It's like trying to sort more toys into more boxes. It takes longer. The way I group similar features, word linkage, stays the same. Only the number of groups, clusters, changes. I'm not changing the method of clustering, only how many clusters I want.